Conditional probability can be a confusing topic. It is very important to pay attention to the details because the results can often go against our intuitions. If we were thinking about the chances of someone making a 3-point shot in basketball, our opinion would depend on whether the person is a professional NBA player or just a kid on the playground. Conditional probabilities work by limiting the sample space in some way, and then considering the probabilities of the restricted sample space. Recall that if all the events are equiprobable, then we can compute the probability of event X by taking the ratio of the number of successes to the number of possibilities. This is the formula for a conditional probability. The notation on the left is the probability that event X occurs given that event Y occurred. We can use the same principle for calculating the probability, but we only consider the cases where event Y occurred. Let's think about rolling a 6-sided die. What is the probability that the result is odd given that we rolled a number greater than 3? Our original sample space consists of the numbers 1 through 6, but there's an extra condition involved. We only care about the rolls where we had a number greater than 3. This means we have to get rid of the dice rolls that do not meet this condition. And now we can evaluate the probability and determine that the answer is 1/3. Here is the notation that we use. The event to the left of the vertical line defines success, and the event to the right of the vertical line is the condition that is placed on the sample space. There's another way to look at this formula. We can turn both the numerator and the denominator into probabilities by dividing both by the total number of possibilities. The numerator becomes the probability of both event X and Y happening, and the denominator becomes the probability of Y happening by itself. We can do this problem again with the new formula, and we see that we get the exact same result. There is another example, which is often called the boy-boy paradox. Suppose that a family has 2 children and one of them is a boy. What is the probability that the second child is also a boy? You'll have an opportunity to explore this question in the remainder of the pre-class activity. In class, we're going to look at an example of conditional probabilities in medical trials. Knowing that a test is 99% accurate doesn't always mean that you should be 99% confident in the result.